story of Ethernet is best told in its personal stories, shared by its very own creators, providers, and users. Welcome to the Voices of Ethernet. This project is dedicated to preserving Ethernet's oral history, recording key events that may have been forgotten or remain unknown through a collection of spoken records and interviews with the individuals engaged in technology's global emergence as the foundation of the internet. Today we'll talk with Bob Metcalfe. Right, Bob is a key figure, potentially the key figure in Ethernet story. Right, many would call him the father of Ethernet. So we really want to hear his account and some of his experiences in the creation of the Ethernet ecosystem. So Bob, thank you for joining us here today. I feel a little intimidated, but could you please introduce yourself briefly?
Just briefly, well, I'm Bob Metcalfe. I'm a professor of innovation at the University of Texas in Austin. This is my fifth career. My previous careers have included engineer, scientist, which is a period during which Ethernet got invented. And then later I was a journalist for 10 years, a venture capitalist for 10 years. And now I've been a professor for 10 years. So I'm about to head off into my sixth career, whatever that's going to turn out to be.
So I should get career advice lessons from you later on, but let us put that to another day. So we typically start off about asking how people got involved in Ethernet, right? So I think most people hopefully know that it's you. So who really invented Ethernet? I mean, we don't often think of there being one guy thinking about it. So like, what's that story just at the start?
First of all, I think a lot of people have invented Ethernet. I mean, it's been 48 years, so there's been plenty of time for people to invent and reinvent. And so, but I invented Ethernet for certain values of I and certain values of invented and certain values of Ethernet. And
getting all sciencey on us.
So a long time ago, at MIT, I graduated and went up the river to Harvard and immediately hated Harvard. So I turned around and went back to MIT to do my, I stayed a student at Harvard, but I got my job at MIT. And MIT gave me the job of connecting MIT to the ARPA computer network. And that was in 1970. So I spent 1970 building a piece of hardware about this big, whose purpose was to carry packets back and forth between the ARPANET packet switch, the original packet switch of all time, and the MIT, a PDP-10 at MIT.
So the ARPA packet switch, was that the thing they called the IMP?
It was called the IMP, the Interface Message Processor. It was a Honeywell refrigerator sort of thing with a ASR 33 teletype as its IO device with a paper tape reader. And I got number 6. So I got the 6th one. The first one is reported to have been in UCLA, where on October 29th, 1969, the first internet message or ARPANET message, however you want to say it, got exchanged from UCLA. That was number 1.
I remember what it was.
What's that?
What was the first message?
Oh, well, Telnet was the only protocol. It hadn't really been developed yet, but it was terminal interaction was the first use of the internet. And so the first thing they tried to do was log in from a terminal at UCLA, and I think it was at SRI, but I'm not sure. There was a host getting ready to be logged into, and the guy, I think his name was Charlie Klein, typed L for login, typed L, and it got echoed. And then he typed O, and it got echoed. And then his computer crashed. So the first interaction, they love telling this story at UCLA, was a religious experience. And lo and behold,
and the internet was born.
The internet was born. So then, having done this at MIT, I went over to Xerox Research in 1972. And of course, the first job I got, since I was the networking guy at Xerox PARC, was to connect PARC to the ARPANET.
So you were immediately typecast.
Typecast, and they gave me IMP number, and I believe it was 11. And my job was to connect IMP number 11 to a PDP-10 clone that we had built at Xerox. And I did that. And then it's got to be 1973, and the lab decided to build a personal computer. arguably the first personal computer, but we're not going to get into that argument. And I was the networking
that was the
guy.
Alto, right?
It was called the Alto from Palo Alto.
And it had a mouse and it had a bit display and all those things. That was
it had a
actually
bitmap
pretty
display,
advanced thing.
which was completely unheard of. It had a mouse, which an idea we stole from Doug Engelpart at SRI, and it was going to have a network, and it was going to have a laser printer. So we built a page per second laser printer. To keep it busy, you'd have to feed it 20 megabits per second. So you couldn't feed it with an ordinary network. You needed a different kind of network. And let me a short story about how I got the job. When I arrived as the networking guy, there was already a guy working on networking there, and his name was Charles Simonier. And as soon as I arrived, they asked Charles to stop working on his network and let me take over. And he was moved on to another project, which was called Bravo. It was a text editor. And to make a long story short, it became Microsoft Office. And Charles is currently a billionaire, lives next door to Bill Gates up in Seattle. But I got he got the $1 billion
there must have been
job.
something in the soil out there at Palo Alto.
But I was the lucky guy who got to design a network to connect. Now listen to this. A computer on every desk. I know, sounds crazy.
Revolutionary idea.
But
and people forget how big computers were at that time. I mean, the PDPs were pretty recent, but even the mainframes were ginormous.
So our goal was to replace the dumb ASCII terminal on our desks with a fairly intelligent personal computer. And I got the job of connecting it. And I teamed up with Dave Boggs, who was a grad student at Stanford. And then he and I built the first Ethernet in 1973. And it was a 2.94 megabit per second shared cable. It shared a 1/2-inch thick coaxial cable that went down the middle of the corridor. And we arranged it so all the attached stations could exchange packets over this shared cable. And that became the PARC Ethernet.
So I know to some extent this built on other work that was happening, but if you think about Ethernet, right, what do you think was the key part of the invention from your point of view? I mean, there's lots of bits and pieces, but what was the key part that really mattered?
Well, I have two sets of answers to that question. And by the way, I've been answering that question for 48 years.
You should have got it right by now.
Well, I'm still iterating. There were three things that we thought were the cool part back in 1973. The first of which was a Gerald tap, sometimes called a vampire tap. And so we chose a 1/2-inch coax to be the shared ether, the shared medium. And this Gerald tap would puncture, literally, you drill a hole and puncture the coax to get to the center conductor. And the benefit of this is you didn't have to home run the network didn't have to home run to some big centralized wiring closet. And two is you didn't have to bring the network down to insert a new PC. You didn't have to cut the cable and bring it down. So that was idea number one. Idea number two was we decided to use Manchester encoding from the University of Manchester, I might add. And the cool thing about this encoding is that we could put the clock in it so that when a packet was sent down the cable, there was no central ticking clock. The clock was in the encoding. That is, every bit cell had two transitions, and that manifested a clock, so it clocked itself into the shift registers at the various machines. So we thought Manchester encoding was cool. And by the way, with the Manchester, the cable was driven only half the time, because in each bit cell, the driver was on only half the time, and then it complemented and then went off, or went off and on. So that meant you could do collision detection. You could tell if you shut off, if you let go of the Ethernet and it was still being driven, then you knew somebody was colliding with you, and that allowed you to abort the communication and stop wasting bandwidth on
thus giving us CSMACD.
That's the CS part.
Yep.
And then, and the CD part. The CS part was you could listen to the cable and see if there was a packet going by, in which case you would not start to send your packet. You would wait for it to go by. You would carrier sense. The Aloha network, by the way, is the third idea. We had to come up with a way for attached stations to take turns sending their packets, and we adopted the randomized retransmission technique that had been demonstrated at the University of Hawaii. And we're about to celebrate next week, or pretty soon anyway, the 50th anniversary of the invention of Aloha network. So the Gerald Tap, the Manchester encoding, and the Aloha randomized retransmissions, all of which are gone now. That is, today's Ethernet doesn't do those things anymore.
Just as a thought on that. So the Aloha was a radio network, right?
Yes.
And so you actually took some lessons from radio instead of what might have been traditionally thought of as wired communication.
That's right. And
that's the shared media assumption.
We wanted Ethernet to be radio also, but it turns out that the modem, which drove the Aloha network, allowed it to be wireless at 9.6 kilobits per second. That modem was bigger than the Alto, or on the same size as the Alto. So we
not very exciting.
So we went to cable, and
So you gave me the first three, the things you thought were important. I think you said you had another three, the ones which actually turned out to be.
In retrospect, Ethernet did three much more important things than those three. The first of which is it delivered packets to the desk. The ARPANET, prior to Ethernet, terminated at the time sharing host, and then a telnet protocol was running over there, and then it would talk via ASCII to a dumb terminal. But with Ethernet, the packets arrived all the way at the desktop. So you could write computer programs on your PC that had direct access to the network. And it was not an ASCII connection, it was an internet packet connection.
So from some points of view, this became the foundation of distributed computing.
That was the term we used, actually. The course I taught at Stanford in those days was called Introduction to Distributed Computing. The second big idea that Ethernet brought was abundance of bandwidth. On one day, I had 300 baud, 300 bits per second, driving my ASCII terminal. And the next day, I had 2.94 megabits per second at my desk. And if you do the arithmetic, that's about a speed up, not of 10%, not double, not 10 times, not 100 times, not 1,000 times, 10,000 times speed up. So after Ethernet, bandwidth became abundant and not superly rare. And the third thing that Ethernet did is it joined the internet standards effort. It was an open, eventually an IEEE standard, and it joined NCP, which was the network control program, Telnet, Ethernet, IP, TCP, HTTP, HTML, URLs, that whole list of open standards. Ethernet was one of them and joined that effort. So those are the three, in retrospect, the three major things that Ethernet did.
So with a vast amount of self-control, I'm going to avoid diving into like the 45 questions I have from that and move on a little. So you've referred to yourself as the brand manager of Ethernet, and I've heard you say Ethernet is a brand. And how do you think about that?
Well, the CSMA CD half-inch coax 2.94 megabit per second Ethernet that Dave Boggs and I built in 1973 bears only a vague resemblance to today's Ethernet. So you have to say, what is Ethernet? That's a fair question. An easy answer is it's a packet format, which then the Ethernet packet format has endured over all these many generations as it's gone from 2.94 megabits to 800 gigabits and gone from coax to twisted pair to optical fibers, and now it's wireless through Wi-Fi. All those changes, there is a packet format sort of enduring in there. But I think the brand, the Ethernet word, carries a brand is a promise. A brand is a promise you make to your customers, and the Ethernet promise is bigger than just the packet format. So for example, abundant bandwidth. Successive generations of Ethernet have delivered much higher bandwidth than was required. and then serendipitous applications were discovered for it. The Ethernet brand has open standards promise. It continues to be managed by the IEEE Project 802. Ethernet has a backward compatibility promise. That is, when you go to, and there have been many transitions to successive generations of Ethernet. And what you see when you look at that history is a lot of effort to retain the install base. And yet, like the Macintosh that I'm sitting in front of here, you plug in a cable and it decides whether it's 10 or 100 or a gigabit per second. That's a little backward compatibility feature there. So those are, oh, and fierce competition. The Ethernet market, since it was open, and the patents for Ethernet were put into the public domain by Xerox in order to encourage the standardization, the competition among Ethernet suppliers has been fierce, and it's wonderful to watch. I love going to conferences, and there's usually an Ethernet panel and the participants go at each other. it's great to watch. So fierce competition, and I think that has driven the cost of an Ethernet port from the high. I sold a Ethernet, my first Ethernet port that I sold for $5,000. And now basically an Ethernet port is free. So that's been quite a
on the topic of competition, the term we often use is frenemies, right? Which is you cooperate to get stuff done and then you compete in the market.
And it's sometimes called co-opetition too.
Yeah. Yes.
Frenemies. Yes, I like that.
Okay, so the other thing I have seen you write somewhere is that you consider Ethernet an innovation brand.
Well, the actual brand there is the Silicon Valley innovation brand, of which Ethernet is an extreme example. That is, Ethernet was developed as an innovation in the context of that machine called Silicon Valley, with all of the features implied by that over time, venture capital and fierce competition and intellectual property and startups and going public and that whole shtick for how you take an innovation to scale as perfected in Silicon Valley. Ethernet is a part of that brand. Our company was in Silicon Valley and benefited from all that machinery.
That was 3Com, right?
3Com, founded in June 4th, 1979.
So again, somewhat briefly, because this could be a 4-hour question, right? The impact of Ethernet on the world, right? So I mean, it's a long summary, but clearly almost everyone who's used a network in the last X years has used Ethernet somewhere. So how would you sort of summarize the major impact?
Puts me in an awkward position because I think the correct answer is enormous positive impact.
Enormous.
Yes, just enormous. So, but there's plenty of credit to go around. I mean, for example, IEEE 802 really performed. So as standards entities are debatable. And that particular one, 802, which we designed, performed. We designed it based on HPIB, actually. The IEEE, when the antitrust lawyers told us that we could not meet unless Ethernet was going to be an open standard, we then looked around to see who would be a good person to make that standard. And we found the IEEE and a guy named Don Lockery at HP, who had made the HPIB, IEEE 488 standard, had just done that. So we asked Don to advise us on how to do the same thing for Ethernet, only through the IEEE. So that's how Project 802 got started. First met at the Jack Tar Hotel, may it rest in peace, in February of 1980. And it's been pumping out standards ever since, including the various Ethernets and the Wi-Fi's, and there's a long list of dots following IEEE Project 802. There was a period where 802 had no dots, and it was Project 802's goal was to standardize Ethernet, but then General Motors showed up with Token Bus and IBM showed up with Token Ring, and then we had to fight for 2 years. And then the IEEE finally standardized all three of them in one of its proudest moments.
I guess that ended up being at some stage, right? We have a bunch of different use cases, let the market decide.
Exactly. And the market did. It took 10 or 20 years for the market. Well, the token bus was killed pretty efficiently, but the token ring with the backing of IBM hung around a very long time.
So I think you'd say that the commitment to openness is one of the key things that fed into success.
Yes, definitely.
So given you have a whole lot of things as your day job, right? Are there any things in Ethernet that particularly intrigue you today?
Today's Ethernet?
Yeah, today's Ethernets.
Well, one of the amazing things is how many directions it has gone. Ethernet, the original one. And I have a list of 5 prepositions that I use. I don't know if I can remember them now, but so Ethernet as a local area network went from 2.94 megabits to 10 megabits to 100 megabits to gigabit. And now it's 800. I'm being told I can put my hand on a box that sends 800 gigabit per second Ethernet. Now they cheat though. They use more than one lambda.
Yeah.
I'm looking forward to terabit Ethernet on a single lambda. I hope to see that before I die. That'll be cool. But that's only one of the dimensions of Ethernet's change, growth over the years. For example, it was adopted in the core. So Sonnet, which was the previous architecture, Ethernet killed Sonnet in the core, which is not a local area networking application. It's the core networking application.
Having built Sonnet gear, I'm very familiar with that particular death.
Well, I was after, what was it called? The one, oh shoot, I forgot. 1.544 megabits per second, T1.
T1.
Yeah, killing T1 was for a while was my life's goal. But then Ethernet was used to bridge what was called the telechasm. You know, you had all this bandwidth in the enterprise, and you had all this bandwidth now in the core, but the service providers were not providing Ethernet speed through their interfaces. So then you needed to develop carrier Ethernet to provide to bridge the telechasm and create bandwidth across that. So there's another dimension that Ethernet began evolving. And then it went wireless in the mid 90s. The semiconductor showed up to make wireless Ethernet practical. That became known. I love calling it wireless Ethernet, which was its original name, I might add, but it's now called Wi-Fi. But we were waiting for Wi-Fi from the very beginning because we had, as I mentioned, we started with Aloha Network in 1970, which was a packet radio network. It took 25 years for the semiconductors to come along that would make that practical. And it is now very practical.
So the vision was ubiquitous connectivity.
Yes, and we chose the word Ethernet, ether in Ethernet, because we didn't call it coax net, because we thought it would evolve rapidly in various media and eventually would come back to radio.
All right, so I am going to get towards wrapping up. So this is a new project for EA. So any thoughts about the goals of preserving oral history from as many people as we can find?
Well, sadly, a lot of us are dying, so you better hurry up.
It's a good reason to start now.
Good reason to start now. I think you'll discover that there are multiple truths. And so I recommend you not make it a project to decide who's lying, who's not about what happened and who invented what, because a lot of it leads to just infantile sniping. And it's just, you know, except
my description at one stage was, what you really want to have this about is the case of, if you're into someone for coffee or at a bar, the stories you might hear. So I wasn't interested in getting a blow-by-blow description of the truth, but more, give me the feeling of what it was like to be there. And everyone experiences this stuff differently.
They did. They went to different meetings at the same time. And so they, when they
were in different bars.
Or different bars. And when they hear what happened at another bar, that they think that those people are lying. But they were just at a different meeting. It wasn't, they were, a different thing happened over there than happened over here. So don't get us so upset about it. Anyway, I think that's an important point to make. There's no point answering the question, who invented this, who invented that. Hundreds of people have invented Ethernet by now, and they're welcome. I mean, there are a few people who overreach, but history will forget them quickly.
So I think maybe the nugget hidden in there is that the core behind this and success has been an enormous ecosystem of people all working in approximately the same direction.
Yes, of course.
All right, so thank you for your time. Do you have any final thoughts you'd like to leave us with?
So Ethernet will be, in less than 2 years, we'll turn 50. And I think we should have a party. And you're invited.
Where should we host this party, do you think?
I don't know. It's being discussed. The Computer History Museum, Xerox PARC. The Jack Tar Hotel has been torn down, so you can't do that one.
I think PARC would clearly be the optimal place to have it.
Well, we had the 40th there, and it's a beautiful place.
If we're going to do this, we'll have to all get together and find some of the gear from the earliest days we can, right? You clearly want to have, you'd want to have a functioning network with an Alto running at 2.8 meg.
Well, there are such, I mean, the Computer History Museum has that. So they should just bring it wherever it's going to be, wherever the party's going to be.
Okay, I'll have to put that on my calendar.
And by the way, the purpose of the party is to remind people about that innovation aspect of the brand. Ethernet has been a successful innovation because of the mechanisms, the IEEE, the Silicon Valley model, the layering of the 7 layers of the internet model with very instrumental architecture. So what we're doing by celebrating Ethernet is we're reminding people about those ideas that worked, and hopefully we can apply them to other innovation challenges in the future.
Yeah, and following on this, it's not a set of written rules about the ideas. It's actually a shared culture that we live. Right? I mean, that's what it's become. It is now a culture of behavior and practice.
Yes.
All right. Thank you, Bob. I really appreciate your time. Hopefully we'll get back and maybe do some more of these, because I feel like I could talk for another 5 hours on these topics. All right, so I am going to close up now. Right, so we appreciate hearing the stories from Bob Metcalfe. Tune in to hear other Voice of Ethernet as we can document the evolution of Ethernet since '73 and really explore the story of where the technology might go next. So thank you for joining. I look forward to seeing you again.
Thank you.